Pirates, RV Life, DJ Darren here. We are working on my furnace. As you know, I have a 1988 National RV with a 454 motor, 34 foot. So it came with this 88 model furnace here. This is a, let me show you the thing here. Hydroflame is the maker, but this would be the model 8535. So it's 35,000 input and then 28,000 output BTU. But it's also called Atwood. But Atwood's out of business now too. So someone else took them over. I can't remember. But so anyway, this is what I got. So basically, I got a Atwood model 8535, which is the biggest one in the series. But Hydroflame. You could also say Hydroflame model 8535. But anyway, so this is the issue. Thing hasn't been running for 15 years, if it was even working before that. So I just kind of got it working by jiggling wires around and whatnot. And so the fan was going on, and then it's been working for a couple days. I've been running it every day for a few hours and making sure it runs, and then it didn't turn on this morning. So I'm checking it. So first the fan was just on, but then nothing went on. It just blew a fuse. So I replaced the fuse. I don't know why that blew. And so the fan goes on, but it doesn't light up. The furnace won't go on. Just the fan blows forever. So that was the original problem. And all I did was kind of like jiggle stuff around. I touched the limit switch, or the airflow switch in there. I kind of just reached my finger in there. I reached my finger in there, was doing that, you know, and then the furnace worked. Now, I think what the problem is when I got in here, this little wire right here, when I went to pull it off, it wasn't really barely even connected. So I think that was not connected, and that was causing the issue. So I redid that. This has to be isolated because it cannot touch that metal. So you see that's an isolated connection right there. So you can't put a bare metal on there. I had to find this insulated one and throw it on there. So it's all good to go. This is called the sail switch. So basically the air blows, it goes blow, and then it hits that switch. It lets it know. So the furnace does not want to light up unless the air is blowing. That would be dangerous. So the air blows, the switch connects, and then it goes to the next thing. The next thing it goes to is right here, which is the limit switch, which is this is 190 degree. So if it reaches 190 degrees, it cuts it off. But if this switch is bad, it's cutting it off. So if this is bad, electricity won't be able to go through here, and your furnace won't work. So originally, you know, when you look through these furnaces, they're like, okay, you know, limit switch is the first switch. If you got power to it and nothing's working, you know, check your limit switch. Then the next one after, check your airflow switch here. I'm sorry, and then your limit switch. So I already found those parts already online. It took a few hours, but I found all the parts I need. And also right here, this little circuit breaker with just a 15 amp circuit breaker. That's it. You could almost use anything, but it's a 15 amp circuit breaker. It pops and pops off. But I found, got the original to put on there, no problem. But that's a generic item. This limit switch needs to be exact so that it can mount right. But it's 190 degrees, so it cuts out, and then this flow switch is just the airflow, but it's got to be the right one, really, so that they all fit in there, but they all do the same thing. So basically that's that. Now I guess I'm going to throw it together real quick and see that if this was the problem here. If it was, that would be great. If not, then I'm going to order this maybe, and then order this switch here too, and order that little circuit breaker, and then there's supposed to be a motherboard in here, but I don't see where, I didn't see where it was. I don't think I have a motherboard on it. I don't know why. It's supposed to be a motherboard, but I didn't see anything in here. Let me look in here. I don't see a motherboard. There's no room anywhere. That's the igniter in there. Yeah, I guess this is no motherboard. So this is a real simple setup then. Yeah, holy crap. Yeah, there is no motherboard. That makes it real simple. That's what I call low-tech. And when you have things low-tech, they really last a long time. Now this, we'll see. The only problem I think this was is the wire was broken on this. So I think I fixed it. So we'll see. But low-tech stuff's great because it'll always work for decades, and there's no electrical burnout or a weird failure. It either work or won't. You know, these are bulletproof in this type of switch. If it fails, it's safe. You know what I mean? Nothing in here is gonna blow your RV up or burn your RV up. You know what I mean? So okay. So that's the deal on that. I took all this stuff apart. It looks kind of messy, but this all goes all back in here. Here's my gas valve right here. So this is a electronically activated gas valve. Once it gets current, I'll explain to you like kind of the series. Now I know what's going on here. So there's power coming into it. Let's see. Now the thermostat basically touches two wires together. That lets it have its power. Then as long as the power makes it past the circuit breaker, then the fan will turn on. The fan will spin and turn on. That's what it does right now. Then it's supposed to go through this airflow circuit right here. So it's supposed to trip that, and then that opens up, and that goes, as you see, the wire goes directly to the limit switch. And then the limit switch says as long as it's not 190 degrees, current can flow. So if it's cold, you know, not 190 degrees, okay, electricity continues through that red line, comes up here and goes in right in here, comes to the other side to the switch, but it basically will then go to the gas valve. That will open up, and then at the split second that opens up, you will have it igniting. Let's see if I can find this. So this is the coil. So this coil goes on here like this. Let me show you here. So this is just basically like a coil, like a motorcycle coil. This is a cap, you know, a spark plug cap. So that just goes on there like that. So when it opens the gas valve, at the same time, it'll spark it right here. It'll send a spark in and down in there, and it'll spark the flame. And then there'll be a flame sensor down in there. And then that flame sensor says, okay, that's that little black wire right there next to the red wire is thick because that's a spark plug wire. So the black wire next to it's a flame sensor, and once it gets a certain temperature of flame, then it says, okay, we got flame. Then it turns the main gas on, and you know, the whole row is lit. The whole furnace is lit instead of just a pilot light. But that's the last step. That flame sensor says, okay, let the full flow go, and then this opens up big time instead of just for a pilot light. This will open up for the full flow, and all of it will light up. But anyway, that's the circuit, and then it's got this little circuit right here if you guys want to copy that. But that's for mine specifically. That's my circuit. So, but yeah, I got the manual for this. Luckily, I got the original manual, so I read through that and some online stuff. So I learned all about this in the last 2 days. And I just got to get this done because it was working, and I moved past it, then it stopped working, and now I'm back fixing it. So let's get this little sail switch going. See if my little fix here worked. Got it all on there nice. Let's pop stuff back together real quick, and I'll just pop it in there, connect the gas line, hook the electrical back up. No screws or nothing, and we'll just see if it works and it turns on. If it doesn't, then I'm going to take it back out, and so that we can have access to all this stuff, and we will order parts. Alright, let's do it. Thank you for watching. Party people, DJ Darren, RV Life, DJ Darren here. We are working on the furnace in my RV, my 1988 National RV. It has the Atwood, or formerly Hydro Flame, but it's called the Atwood 8535 series. It's the first gen, so it'll be 8535-1, first generation. We're having an issue of the furnace not kicking on. First the fan would go on, and then no heat, it wouldn't kick any heat on. Then that stopped, and then it went back to the fan going on, but nothing else kicking on. So what we did is we replaced all the little parts. The problem was the time delay relay. There's the original one right there. Here's the new one I found on PDX RV wholesale. So PDX RV, they had the cheapest one. It's $33 or something plus tax. So let me just explain what we did. So I replaced the limit switch, 190-degree limit switch. That's brand new. That was only like $10 or $8. So replace that. Also replacing the sail switch. Even though the old ones are probably good and they tested them good, but I want brand new. These are only, this is $8 and the other one was $12. So I'm going to replace them, and I'm going to keep the old ones in a bag just in case I need some spare parts while I'm on the road and I don't want to order. But I always want new parts. So it's a no-brainer. If you're working on your furnace, then replace these little cheap parts. You know, don't be stupid. I also replaced the circuit breaker. Now, the original one, they didn't really have it. It was like $30, crazy price. So I just found the identical model. This is just a regular 10 amp circuit breaker you can find. So I found the exact same model style that I could mount, and I bought this for $10. So this is a well-functioning 10 amp circuit breaker. That is a circuit breaker for the fan. In case the fan takes too much energy, it cuts it, and then you just come in there and you push that and it'll work again. But anyway, so that's $10, $8, $12 sail switch. This is called a sail switch. That's what I replaced. So found all that stuff, did my research, replaced all that little stuff, and then the problem is this. Okay, my old one. Now I should be showing the picture in the video here. My old one has the same. Now if you look at the diagram, it has the same diagram. It says thermostat on one side, ground on the other, and then the other two are 12 volt and motor. Now basically it's just a relay. So you supply power. You're supposed to be able to supply power across at once. So let me show you the diagram here. So you're supposed to supply power to the thermostat side. Okay, when you supply power to the thermostat, it goes through the relay and grounds it, which activates the relay, and then that connects the 12 volt and the motor. So if you supply power at the thermostat right here, boom, and this is grounded, it should now turn your motor on. It's supposed to turn it on in 2 to 3 seconds. So that's what this is. As you see, it has a 4-second delay. 4-second delay to turn the fan on, and then when it turns off, it has a 2-minute cooldown. Okay, now my old one has the same diagram too as well. It says, you know, T-stat, ground, 12 volt motor. The problem is this: when it was hooked up, now I should be showing the diagram of it. I'm having power run to where the ground is. So this one, I'd be having my thermostat there, and that goes to the motor, right? And then this should be positive, and then but it also has positive, so it has positive running to the ground. So if you look right here, the original wiring on this thing has the positive as another clip here. So you see on how they had it wired on mine, they had the positive going to the 12 volt and to the ground, and then the normal one going to the motor and then to the thermostat. So to me, that's an issue because I don't want to run power to this ground. On the back of this, it's very nice. It's got a diagram. I don't know if you can see that, but it says T-stat, motor, ground, and positive. So on the back of it, it shows you which to hook up. Okay, the only one in question here is this one, that's the ground. So the original one had power running, you see it just runs straight to that ground. So I would assume that the thermostat is grounding it. So when you turn your thermostat on, it grounds the circuit, and then that's what happens. So, but that says it's supposed to be ground, not positive. So normally that would be ground, and then your thermostat would be hooked into that, where the blue is, and it would send positive to it, and then activate it. So I'm a little bit hesitant to hook this up. This part cost me, $40 cent. If I hook it up wrong, I'm going to burn it out. So I don't know what I'm going to do here. I could physically run a ground to this and see if it works or not, but we'll see. I don't know. So that's my dilemma, guys. I'm gonna have to figure this out. I don't have my RV here right now. I'm just working on my furnace, so I'm gonna figure this out and see. I hope I don't burn this out and have to buy another, but that's my dilemma now. So it wants me to hook positive to the ground, but I don't want to do that, and I didn't see anything online, and this is the only one. This furnace is the only kind of one that's wired how it is. So that's my problem. Here's the old one, and I'll show you the little diagram here on my furnace. So there's my furnace diagram, and as you can see right here, here's my relay. As you can see in my relay here, okay, there's my thermostat. There's my thermostat wires on this side, the blue ones, and then there's the red wire directly to my motor, okay, and then this is red coming in, but they also have red coming in here to ground, but on the diagrams it shows that as ground. So maybe I should just connect it. They want hot here and they want hot here, but this is supposed to be ground, but this is how they have it hooked up, and I believe that the thermostat grounds. So they should have explained that. So it looks like the thermostat grounds this relay. So we'll see. So that's the diagram for that. If you guys want to see, that's the operating diagram for my furnace. This is for the 8535 Generation 1 Atwood furnace, formerly Hydroflame furnace. And this would be, this RV is 1988. So that's my dilemma, guys. I'm going to try and figure it out. Put all my other parts in. I'll probably just hook that up, power to that ground, and just cross my fingers, because that's how the other one was hooked up, and it worked like that. So, but I don't like it, I'm telling you right now. So we'll see how it goes. Wish me luck. What's up, everybody? RV Life with DJ Darren. We're doing a furnace update. My furnace is working perfectly now. Finally, after a whole bunch of different work and whatnot. Well, I'll tell you what, I am now probably certified furnace repairman, because I had to do everything and learn the entire system and everything to fix it. But it was exciting and fun, and it's old tech, so it's not so bad, It's 1980, really 1987 technology. So anyway, let me give you a breakdown of what's going on. So there's my furnace right there, as you see. It's the Atwood 8535-1. So it's the first in the small. It had a 1, 2, 3, and 4 model. This is the first one. This one's unique in that the thermostat right here is negative triggered. So all that means is that, see these two wires? They come down, they literally come down inside there into those blue wires right there. All they do is connect a ground. So they connect the circuit to the ground bare metal, and all this is, as you can see right here, it's just, hold on here, let me try and, sorry guys, it's a little dark there. All that does is right here, is connect. So that pushes forward and connects, and that turns it on. And then basically just completes the ground circuit, is what I'm saying. There's no power runs through there. You mechanically do that, and it mechanically closes, and that lets the whole circuit ground. Now that's what became a pain in the butt doing this furnace, because all the other furnaces are positive thermostat, which means there's a positive 12 volt wire going through that, and it's totally different setup. So you have electronic thermostats don't work, all that stuff. So you have to stick with mechanical. And also I got the wrong circuit board too as well. So let me give you a breakdown. So basically, let me get down to the floor here. So basically, I replaced the sail switch because it had a problem. It was working with the heat, and then it would only go on and blow cold air, and it would never heat up. And so I replaced the sail switch and the thermo switch, and then that didn't make a difference. And then so I bought another Dinosaur Electronics upgraded circuit board, but that was only for a positive thermostat, not a negative, and I couldn't get it to work. And I even talked to the main tech guy who knows what's up, and we couldn't get it going. So I returned that, and I got the one. So this is my original right here. This is my original circuit board. Something went wrong with that, because it would still just go on, blow cold air, and it would never trigger, you know. And so I wanted to replace the circuit board. This thing's, 34 years old, and Dinosaur Electronics has a much better one. Now I'm sorry you guys, I already glued this one in there, but I'll show you which one it is. It's the Dinosaur Electronics. The model is the UIB L post, and the L post just means like this, like a knob. The other post would be like a flat plug, like you would plug a flat electrical wire onto. But the L post is more like a spark plug wire, basically spark plug cap. So spark plug cap will pop on it. So that's what I have on this. This board was an exact fit, but I did have to drill out this hole here. So as you see, I did that hole myself. Super nice. And so now it's got room, but that doesn't stick up as much. So I cut some of the rubber off the spark plug cap, and it'll pop in there nice. So it's going to pop in there all nice, and I'll seal it up so it doesn't move. With rubber glue, I'll seal it so it stays in there. But the other one sticks up farther. So, but it's going to work perfect. I did the rubber glue and secured this board in there and made the hole so it's all nice. So it's all ready to go, and that's just going to mount right there on the side like that. And it'll be inside. It goes inside there. But anyway, it was awesome. That only cost me $80, I think, on Amazon. So I'll leave a link for that. So that board's awesome. So happy to have that. So I got that, and then I found a new sail switch, $10, and a thermo switch. The sail switch is what moves. It senses that the air is blowing, and it moves, and it completes the circuit. So I replaced that anyway. I wanted those new. And the thermo switch makes sure it doesn't get over 180, and it allows the circuit board to know what temperature's going on in there. But anyway, so there's that. And then I added a fireproof board. So this is like fireproof drywall. It's not as thick as normal drywall, but man, it's super thick. It's fireproof. So I wanted something fireproof underneath the furnace, just to feel safer, because it's just the wood. Even though these are pretty much 100% fail-proof and whatnot, I didn't want the wood heating up underneath it. So I got this nice little thing here, as you can see. It's a little less than half an inch, but it's thick, it's fireproof, and so it'll protect the heat and all that from going into the wood and whatnot. So I did that, and the way they originally hooked this thing up, they only had 3 outlets coming out, and it was a mandatory 4. So I read the manual for this furnace. It's a mandatory 4 coming out. It's supposed to be 4, so I'm adding a 4th one. So this one goes out that way, this one comes down over here to there, and then I'm adding another one right here that's going to come around and come out to a new area right here. And then I did this little trick. Before it was taking in the fresh air right there from there. Now I'm going to still have that screen right there. That's going to be like one of those, but it's going to be right there. But this is all going to be a sealed compartment right here, and the furnace is now going to be taking in the fresh air. So I'll be able to put a filter over that too. I'll have a slide filter I'm making for it, so I'll just slide a filter right on there. It'll be filtered air coming in and being pulled through the heater. So all my furnace will get fresh filtered air and whatnot. And then I suppose too as well, the way the system is going to work is when it's on very hot days and I'm not running my furnace, it's going to pull fresh air. Fresh air is going to come through here. Colder air from below the RV is going to be pulled through here and then through there and out. And I added another one too as well in the back. I added another floor vent, and I'm adding another floor vent up there so that on hot days I can have cold air being pulled up from the floor area and helping cool the RV. But anyway, yeah, there's my furnace, and then I also, I mounted I made these little boots right here. It was a whole beam going across there, like one of these, but I want air moving underneath here. I don't want nothing blocking it, so I made these little feet, and I'll put a little screw there, put a little screw there. This is loose right now, a little bit loose, so I just was test fitting it. And then I got one vent going in the back there, and I'll make sure that's all sealed there so no air can get pulled from there. So I want this a nice sealed box, so that the only air getting pulled through here will be from this vent, and then I will have this will be blocked off most of the time when I want it. But anyway, so that's the furnace stuff. Very happy with the Dinosaur Electronics upgrade. There's some old circuit board, pretty interesting, They make identical ones too as well, but the problem is the new ones, they have a fan control circuit on them. So they have 2 little tabs, and it controls the fan. It's supposed to control the fan so the fan doesn't go on. If it's cold, it senses that and it's not working, then it shuts the fan off, because otherwise the fan will blow all night even if your heat's not going, and it'll kill your battery. So the new ones have a fan control, but they don't work. They're only for positive thermostat. So none of that shit's going to work. So you guys are going to want to get that. If you got my model, you're going to want to get the UIB L post one, and it's $80. I mean, it's superior electronics too as well. The capacitors and whatnot, it's heavier and superior electronics. It's a lot better. So very happy with that. My cost of parts is like $100. Otherwise, the new furnace is $800 or $900, and the cost of my parts is $100, and it's basically the whole guts. I mean, the circuit board's the whole guts, really. That's the biggest cost part. So now I got a new furnace going, and it's going to last forever. It's reliable. It's going to be great, and I love it. And I got nice fresh air coming in here that'll be filtered. I'm going to be cutting up these filters to make little slide filters. So it'll be a little slide filter. We'll slide in there and slide out. And this will be a door right here. But very happy about it. So knock that off my list. Furnace is good. Got my heat.